branch so people can follow along if they want to watch the development on the development branch. So that's what I was in the middle of doing just now. What do we got? Let's see here. Any new information? Nope. So far, no. I don't have a long time. I only have like a half an hour, but I wanted to put this out there and show what's going on for those who've been following along. And I just need to push this branch. Frankly, I'm not very good at pushing branches yet. Let's see. You guys are gonna laugh. Am I streaming? Maybe I'm not. Yep. Okay. So git pushing a local git branch. So for those who want to follow along in this saga and are okay with looking at a branch that does not work, this is good at dev. What the heck? Graphena branch git push remote. We did that. Actually, git push specifically. Git push origin feature. Yeah, but if you need to push a branch name feature to the origin, you would execute the following part: git push origin feature. I don't know. I should know how to do this. I'm like a little embarrassed. So I don't do branches a lot. Hey, Varzi. Git push. I kind of want to do. Do we do it to origin? I think it's an origin push. A local branch pushing or a local branch to remote. It's like one of the most common things people do, except for me, because I don't git push origin master. I don't want to push origin master. I want to push a different branch. I think it's git push origin and then the branch. Yeah, I'm pretty sure it's I think it's set upstream or something. Git push -u origin branch. That's what I want. Git push dash. Okay, u origin one file. I don't want to blow away what I have there, but should be fine. That's what I wanted, and now it's telling me if I want to make a merge request, which I do not. File from origin. So let's go. I just want to look at it real quick just to make sure. gitlab.com/pegn/pegn-go. It should have a branch or two. I have master and one file. Yay. So yeah, one file is pretty big divergence. I won't lie. It is weird. Although it's just one file. So that's actually what I want to talk about. So I talked earlier in the day about the task of getting all this in a single file so people can include grammars and generate grammars that are in one file and they don't impact the rest of the project. And before the next step, which is going to be non-code generated grammars that use the package. Actually, I really want to say this. There are two distinct approaches to using this. And I'm actually going to write them down. Two distinct usage, let's see, use cases. I don't know if that's even the right word for this package. One is to generate a standalone. Actually, there are three. Number one is to generate standalone, autonomous, whatever, a standalone single file for a given grammar. All right, that's the number one. That's really the most important. So that means that people using this can generate, they can submit their own grammars, make sure they're fine, and then generate using the peg tool or whatever their own grammar. And this is something we eventually will put online, so people could actually, cut and paste their grammar, and they can use it through the command line or whatever, and submit it. And the thing they get back is going to be a parser. So I'm so excited about that. So it'd be the parser with all the nuts and bolts, and it'll be guaranteed to not be name collisions with anything, because they're going to specify the part of entry, the part of entry and everything. So that's the number one. And then the other way is like incidental use by importing the package and using peg inline. And that is really cool. This is another really amazing thing. Once we get it going, I really can't wait to get it. That's why I'm so focused on this, despite how much it hurts my brain. I am not a computer science genius. I'm just going to tell everybody I love this stuff. I have strengths in other areas, but I'm a great coder. I have a great work ethic. I can figure out, complicated things. I got high level math and all that, but I've seen other people that like burn through this shit, and I tell you what though, they got other problems. They tend to make things too complicated, unnecessarily. They tend to have code bases that nobody wants to maintain. I'm not exaggerating. I've known these types. So some of this is kind of, I think it might be a not liability to be dumb, a little bit dumb, because it makes me do things in a way that it's very practical so I can feel them. Bonus stream, Greg, I got to come back. So, and then the third way is educational evaluation of how grammars, graphs, and I guess how grammars, ASTs, and such work. So those are the three main reasons. And so I just wanted to say that because as I'm going through this, there's two really distinct, important ways, and they're really both powerful. One is this standalone file, which I'm not going to finish for the next 30 minutes. I'm going to work on it anyway. And the other one is this use a, let's see, inline parsing, inline. So this is so fucking cool. I cannot wait for this to work. Inline peg grammar parsing regex replacement. So yeah, those are very real possibilities here. I'm going to clean up some of these errors over here too while I work on it. But so this is Ethan and I figured this out just now in our session, that we actually can almost directly take the code that has already been written for the AST and then just make it inline here. And let me just give you a sense of what is done when you don't do it this way. So this is pegleg. Anybody who can tell me that they want to have this code in their code base, raise your hand. I do not ever want code like this in my code base. There's lots of people that are okay with it. They're like Lex and Yak and shit like that. But when the thing breaks and you don't have your code generator anymore, somebody is going to have to debug this thing. And I know you don't think that's going to happen. You think that your code generator tool is always going to be there. It's always going to be fine and dandy. But this code generation, this is from the Go Peg project, which is based on the pegleg project. It might be wicked fast, but look at its excessive use of GoTo and stuff like that. There's no way you're ever going to understand this code. You might as well consider this, pre-code compilation, and it's not uncommon. But the thing that really kind of got me interested in this is why I pulled this up just to remind myself, is there are still a lot of function calls going on in here. So it might look like it's more effective and efficient because it's all embedded and it's using scoping through, through brackets and curly brackets and stuff. And it's using, official, good use of GoTo to jump by and to skip code and blah, blah, blah. These GoTo calls, so they're long jumps. They're underneath. They might be a little bit faster. A function call is just a pointer, so it's not that much slower. And so I'm like, why on earth would you do this? And I know there are reasons, right? But why on earth would you do this when you don't have to do that? I mean, and this is what I'm kind of coming across right now. what's that? You know, so yeah. And so what I'm preferring to do is what they do in Haskell. And so the Pandoc project, thank God I looked at the Pandoc project. Oh my God. I am so happy that I learned enough Haskell to study the inner workings of the Pandoc project. It's wicked fast. It's way fast. They're fast enough for anything else. Is it, going to be the world's fastest compiler? Probably not, but they use this approach. So they use this parse function approach, where they take its very functional approach, which I love, love, love. And it says, okay, I'm going to put this thing in here and I'm going to get it out. And as you can see, the pattern emerging, this now no longer has a dependency on our crazy expected and check, functions with the pseudo syntax sort of thing that I had going on, which was cool. But instead, what it does is it redundantly copies the things that it needs to. So if I see a rune here, I get this little block of code every time, and that can be really generated rather easily. The difference between this and this is that I can fucking read this. Yeah, so it's a little bit longer than it was when I had the expect function in there. Oh well, the expect function was like 2 or 3 extra function calls per call, so that's all gone now. So this already increases the efficiency of the entire existing parser we've already written by a factor, I would say, of 3 or 4 probably across the board in speed, because there's no indirection. It's also all using structs, so there's not those extra interface function calls. We don't need those. So it cannot possibly be that much slower than the other one. Now, I won't know until I benchmark, but I'm super happy about this, because this means that even the generated code from pegn, from the reference implementation, is going to be easy to read. It's going to be functional, not like it can function. It's going to be a functional basis, as opposed to, really dependent on, an object. This stuff is not. And I actually really seriously considered whether passing a pointer to a parser is slower than having, and therefore kind of an object-oriented way. It turns out, no, this is just as fast as making it a receiver, but it's functional, it's more flexible, and it's faster. It's easier to test across the board. So, and this is, this, we're talking about generated code. So usually generated code has nowhere near this level of testability and fixing. And another advantage of this that I really just want to put out there that I'm super happy about is that when you do this, when you need to make those kind of punts where you have to change the code a little bit, like for indentation or something like we had a problem with before, you can go in here and tweak the code in the generated thing. And as long as you don't need to regenerate that code again, and even if you did, it wouldn't be that bad. You could go in there and tweak that add your tweaks to it without losing your fucking mind trying to figure out what's going on here. So I'm, once again, I am a fan of this approach. I'm glad that Pandoc has kind of shown me the light. Frankly, functional programming has shown me the light. And I more and more, I just starting to really detest object-oriented programming, at least class-based programming, because there's just so many other flexibility things that you can do this way, and it makes me want to code in C even more. All hail functions, and I am really getting into as you know, we use first-class functions. We have practical object-oriented programming, right? Pragmatic object-oriented programming. So this is going to lend itself very well to C coding, because the function calls we do have are being dealt with as first-class functions, which means they're just being passed around like crazy as pointers. So I'm happy about this. I'm going to keep working on it now, but I did want to kind of give a summary. I got kind of excited when Ethan and I made this breakthrough. It's not that big of a breakthrough. Anybody who's, head deep into computer science would see this and go, oh yeah, you figured out how to do parse functions. Hurrah, welcome to functional programming. I'm sure there's somebody out there saying that to me right now, and that's fine. You'd be totally justified. But, to me, this is kind of cool. And so, yeah, I'm just going to pursue this. There are a couple, things that are going to be interesting in terms of generation, but I'm not going to deal with that right now. I also don't know whether I'm going to clean up my errors before I start porting over a bunch of these other functions. And people are like, why don't you just write a script for that? And at this point, I did write a script for the classes, as you guys saw, but this stuff I feel like I don't want to write a script for just yet because I'm unpacking a lot of stuff. I'm unpacking the stuff that was the magic that was done in the expect function, as well as, kind of inlining it. And I just want to be really, really sure that that we're looking at. See, and you can see the patterns already, right? I mean, it's like right here, it's like, oh, I'm a rune. This is what I do. I make a function with this thing. In fact, it's becoming so easy to guess what the thing is going to be that you can tell that by walking the tree, you might not even have to generate code. You could just call the code and do the evaluation. And that's phase 2. That's coming next. And that's for inline code. Once again, just to review, that's so we have our different phases. We have generating standalone single file for a given grammar that can be automatically generated through a service or something and is plopped into your code. And then we have inline parsing using the library. That means you use the library and you call function calls and pass them a grammar that's as a constant, and then you pass it the input and it evaluates it in real time. That's going to have to do the parsing on the fly. So that would always be, a different sort of parsing. It'll also have to parse the grammar in addition to the data. So that'll be slightly slower. Slightly slower, right? Because it's not generated, it's not compiled. It's got to do the parsing for the grammar and the parsing for the data against the grammar. So those two things should slow it down, but not much. I expect not any more worse than a current regex would do. All right, so and then just the educational thing. I've debated long and hard about whether to keep this stuff around. By the way, if anybody wants to follow along with this really, really boring work, as I said, this is in. It's in a new branch. I put it in one file branch, and so it's not gonna, it doesn't compile, it doesn't test or anything. But that's just, if somebody wants to follow development on that branch, they can just follow that. Because I'm growing up, I'm a big boy in terms of Git. I'm starting to use it as people have had for a long time. All right, so pegn I find boring interesting. Yeah. So here we have all of this. I am going to make an effort to clean up the errors that are being generated right now, and see if I can get some of those fixed up before we go on. Actually, you know what? It was actually pegn-go. Yeah. I can objectively prove that. The very first version of this I did 2 years ago, and it felt like 2 years, maybe it was one. And it was P with a schwa, and it was a G and an O. It was back when I was doing conversational interfaces, and I did this. I started a version of this and abandoned it because I was like, no way, man, I got so much other stuff to do. Obviously, this is taking time, and it was called pegn-go. And because pegn-go actually has a name, Jenny, doesn't it? It's Italian or something. Yeah, I seriously thought about doing that, but anyway. I went with pegn instead this time. So we might still have to do that. Maybe we have to have a rebranding at some point. Who knows? Undefined piece. So I'm going to clean up some errors here real quick and make sure. I kind of want to get this, so even if it's, I don't think I'm ever going to be able to get it error free because I'm going to be pegn the file pegn. It might still actually exist. All right, so I'm just gonna do some more of these. There's no hope for errors for now, unfortunately. So you can just go away because they all have interdependencies. So either all has to work or not. So I'm gonna just do them one at a time. So that the next one we're gonna bring in is, well, I'm just gonna look at the spec. Actually, that was working really well, and Ethan and I were doing it. So the next one in line would be, I don't know, what is the next one in line? It would be alpha something. Nope, it would be, I suppose it doesn't matter. You know what, I'm kind of trying to, how would this get generated? Would it be, it really doesn't matter. I almost think we should put these in here alphabetically just cause. So in that case, let's actually go see what comes next. And thankfully we have all of those listed here. Alpha range, AST does not get done. And then, so binary. So let's do a binary. Binary, here we go. A binary is a B and a bindig. So that should go pretty fast. All right, so binary. Again, this is going to be really unnerving. Thank God you only have to see a few minutes of this before I have to go. But it's not going to go fast, people. I'm just going to tell you right now. A lot of this stuff, you're going to be like, please write a generator for that. And I might have to just write a shell script for some of it for right now. And there's enough of it that I just want to do it by hand on purpose for now. So we have a pegn type of binary. Again, imagine all this being generated instead. So that is standard. So that template right there. It can be created automatically for any node. I'm kind of tempted to make that for everything right now. To just stub everything, because everything has to have that. Every single thing has to have that. And then the next stuff is kind of like, do you need the extra stuff here? In fact, I'm like really seriously tempted to do that. I'm going to do it right now probably. Because that we kind of need an HTTP template for that. I think Quint's not here. That's too bad. You know what? If I come back online tonight, that's what I probably will do. Probably tomorrow too. I don't know. We'll see. But yeah, I'm really feeling the pull to do this automatically right now. And there's two ways to do that. I could do it automatically by writing a shell script to write it, or I could actually start writing the generator code in the pegn tool and use templates. And just actually, God, I could even just use test cases and generators for that. To do code generation. If you're doing generate inside of, you know what I could do? I could just, you guys are going to laugh. So this is something you can do with Go. This is one of the reasons Go is so awesome. You can actually use Go as a shell script. Yeah. Like, why would you do that, right? Well, this is one of those cases where it might make sense. So if I say, if I do like, I don't know, make, gen something. Gen what? Gen node parse. Gen node.go. And I can do this, and I can say, actually, I should be able to just run this one. I might not, because it's in the package, and this package has problems. So let's just be sure about that. So make util, cd into util, and then we just do gen.go. And we could say, well, frankly, I could just make a util here, iterate in folders and go find get folders. Yeah. So, I can just make this. No, I just do this. Make. I'm gonna be ripping this code off anyway, so. I mean, I'm already sort of making my decision not to do this in shell, obviously. So I'm going to call a thing called gen, and I'm going to make this into some sort of stupid tool for now. Gen.go, and we'll just use HTML templates. We'll leave it be main. I'm going to go ahead and save this, and let's just say, well, let's do. I get this code. You guys have done this, right? You know how to do this. Well, I mean, so this one I can just do go run and, gen and just do it. All right, God, I could even install it, for God's sake. Which gen, go install. I just do gen and I get nothing. I get nothing. Gen print. Blah. Yeah, install gen. I mean, it's not easy to do. It's not. I guess I didn't even have to do it as a shell script. I was going to show you I could just run it from the command line. It's so easy to make a command. So again, I'm just going to do this. So gen, we'll make it. We're going to use some HTML templates, which I'm going to go pull up right now. I wasn't planning on this. So this is kind of fun. I haven't done text template in a while for Golang, but it's super cool. It's kind of like Perl F format, if you know what I'm talking about. And there's an HTML version of this as well. So So I really need to get better with it because it's used. This is the basis of Hugo, by the way. If you're a big Hugo nut, you'll know about this. And I mean, he can do so many cool things with it. This alone, the template system in Go all by itself puts it head and shoulders above anything else in the web space. I swear to God, it is so amazing. This is why it's so used for this kind of thing. I do need to make a template though, and I don't remember how. So I'm gonna go read up on how to do that. I've made them in the past and done stuff, but I haven't done it in a long time. Functions. No, not using any of those. There's like built-in functions inside of the template language already. So yeah, and they all compile down to compiled code, so you don't have to deal with like parsing and runtime like you do with JavaScript. So it's just so cool. And you can import other things, everything. So the first step I think is you need to make one. I need a little tutorial on this. There we go. All right, so func main, define a template. So we're going to define a template constant letter. Let's do that. So is it defined? Constant, yeah. Constant, we're going to call this node parser function. Node parser. That's what these are. These are node parser functions. And we're going to make it a constant. And I'm going to actually put the whole thing in here. So func, you know what? I'm going to rip the other one out of here. That's what I'm going to do. Yep. Pegn-go, and I'm going to go get this one right here. I'm going to rip you in here and put you in my template. And you are now a template. All right. So what thing varies here? Well, we got this thing here, so I'll need to put something there. I don't know what to call that. Let's call it, it has to be exported. So let's do dot ident. Okay, and then, well, that's all good to go, good to go, good to go, good to go. Right here we have a lowercase. No, no, it's actually the same. Actually, I think we want to do lowercase of the ident, which I think you can do with their transformation thing. So yeah, this is the lowercase of the ident, and then so we're gonna have stuff here too, but I don't know what. So actually, the crazy thing about this is we could, I mean, this middle part we could iterate over this. So, I can do an if statement right here too. Yeah, that's going to be great. And so this part will make the body. God damn, I might even be writing the generator code right now. This is gonna be, I'll call it the body. This stuff we might actually have to figure out how to do it in order. We might actually be able to use the template syntax to loop through the pegin syntax and then generate those things and dump them in. Oh shit, it's going to be awesome. I was not planning on this. So this is the preamble. So that's like all the stuff we might have to identify, and then we have the body in the middle. But just let me show you how these things work, just to refresh myself too. So you have all that stuff, and then what? Then you have to compile it. You have to have a thing that goes with it. Template must create a new template and parse the letter into it. Template must, you get a T, and then you can execute the template. So let's do that. So let's say this is the line I need right here. We're going to say templates. I don't want a template. We'll call it new. Wait. Why is it calling it new letter partially? I don't see letter anywhere in there. Oh, constant letter. That's interesting. Oh, you can actually give a template a name. I don't remember that part. So let's call it node parser. So you can keep these templates on file, I guess, and in your, you can probably compile them all in your init, and then just have them available in your generator or whatever, and just pull them up. So pegin node identifier. So we're going to use pegin_node here, and yeah, then what? So we have a template. And then what? We have our stuff that we need to do. We need our execute. So let's actually make a thing that, and it's actually any struct that has stuff that matches. So we could say, we could say node info. I mean, in this particular case, like, it doesn't matter. I don't think I can define it though in here. Yeah, go type. I don't think I can do it. That's gonna have to. This is in the main. Can you define types? I don't think you can. I think it's going to complain at me. You can't do this inside the main function. No, you can't. Can you? I guess you can. So then we're going to say node node parser. Node parser, and is a struct, and it has an ident, which is a string, and it has a preamble, which I can figure out later. Preamble, and then it has a body, which it was a string. I mean, I'm just making room for stuff later because I might as well. And then what? Then we go over here and we actually do t.execute, and we give it a one of our things. We got to make one. So I could make one. I could say Rob, node parser versus node parser sort of reflected the capitalization. You sounded much less excited about node parser. Node parser. Node parser. Node parser. Node parser. So here we go. Let's do this. Let's do so I don't know. I could say no. Let's do, what's the next one? How about binary? Binary. So binary is a is a node parser, and it has what? It has an identity, binary, and it has no preamble, no body. So actually I can just do this. I mean, for now, I'm just getting used to it again. But yeah, this is definitely going to grow into something better. That's why I didn't do it as a shell script, because this is going to grow into an actual generator piece of code. And so then I t-execute on binary, and we should get a string out of that. And if you execute this stud out, it'll tell you where it's going to print it. Let's do os.studout. Studout. Sorry, Mike. Here. Oh, fuck. All right. How about that? All right. Let's try it, boys and girls. Go install. Fuck. Line 28. Binary equals a node parser. Node parser. I need a node parser. What was the error? Too few values. Suck me. All right, fine. And to the fine. Nil and nil. How about that? Actually, no, it has to be empty strings. Duh. Yeah. And then what? Undefined pegn node. Really? Oh. All right. I believe you. You're right. I'm wrong. Boom. All right. So Jen, yay. It's a little bit ugly, but So obviously with shell, I could have done that much faster. But the difference is that all of this extra overhead in developer time is going to pay off. I do have to go to my next session. I have some sessions tonight for mentoring. But how's it going, Mobile Curie? You got here just in time for me to leave. Welcome, though, if this is your first time. So yeah, there's definitely some advantages to having a preamble and all this. In fact, let me do it this way. It won't be as big and annoying. Mentoring. Yep, I do have. I have mentoring starting up. Sure, we'll do whatever we can here. As much as I can do to help people, I will. Well, the mentoring I do professionally does cost money. Yes, it costs you the same as violin lessons. So you know, so I'm not gonna. By the way, I have a couple. I had another open spot come up after right now, which is why I'm doing this. About $57 an hour. Yeah, about $1 a minute. That's what I do. But it's just, it's because it's a hobby. If I want serious at this, I'd probably charge double that. But, I like keeping things really informal. Which, speaking of which, I'm going to get interrupted here. So I'm going to go ahead and shut the stream down. I may or may not come back tonight. I'm really excited about this whole code generation thing. It's kind of a new thing. It's not new. I've done it before, but it's not, trudging through all the other stuff.